Welcome to Serenity, Game Systems Foundation. In the previous video, we integrated Serenity into an existing Unity engine project. We started from a simple side-scrolling runner, installed Serenity, connected the existing game scene to the initialization flow, and verified that the game still worked correctly. In this video, we're going to make the first big visible changes. We will add gameplay sounds, menu music, gameplay music, and we will replace the hard-coded game over text with a modal. So this video is where the integration starts becoming much more noticeable. The first thing we're going to do is a small but important project organization step. We need to move the media and scenes folder out of the Serenity plugin folder. The reason is simple. Anything that belongs to our game or to this specific integration project should live outside the plugin folder. That way, if Serenity is updated later, our project-specific scene and media files won't be overwritten. The plugin folder should contain the framework and the project folder should contain the game-specific implementation. So, let's move the media and scenes folder into our own project area. After moving the folders, we should make sure the project still compiles and the previous scene references still work. Now we can copy the sound and music asset that we are going to use in this tutorial. We will need short sound effects for gameplay actions and music tracks for the menu and gameplay state. For this game, we're going to use sounds for jumping, landing, and dying. And for music, we will use one track for the main menu and one track for the gameplay. For this tutorial, we're going to create definitions for the main gameplay sounds. Each definition should have a clear name and a stable identifier. This identifier is what the other parts of the application can use later when they need to request that sound. Now that the clip definitions exist, Serenity still needs to know that these sounds are available. So we open the game settings and add each audio player clip definition to the list of available sounds. This registration step is important. It means the sounds are now part of the application's configuration. From this point on, Serenity can resolve on playing these sounds through its audio systems. Create a new Unity Event Dispatcher signal definition. This scriptable object provides the configuration needed to dispatch an event dispatcher signal. Select Play Audio Clip Signal on Signal Type field. Select the parameterizable constructor. On Parameters section, choose the corresponding audio service responsible on playing the sound. Choose the audio player clip constructor. Set the proper audio player clip definition. The next step is to trigger the proper sounds. Go to the player prefab and add the SignalEmitterComponent. The first sound we're going to set is landing. Locate when the player has landed and trigger the sound using the SignalEmitterComponent. Do the same for jumping and dying. And the next thing we need is to check these new sounds are working. Let's start a new game. Now that we can hear feedback from the player, the next step is configuring music. We need to create music track definitions. In this game, we need two tracks, one track for the main menu and one track for the gameplay. The main menu song runs at 120 beats per minute and its loop starts at bar 2 and ends at bar 10. The gameplay song runs at 150 beats per minute and its loop starts at bar 2 and ends at bar 134. This loop information allows Serenity to play the track in a more musical way, instead of just looping the entire audio file blindly. Now we go back to the game settings and add these music track definitions to the list of available songs. The next thing we need to trigger the music is to create the signal and action pair. Create them using the context menu. Once created, update the action in order to use the music player to play the specified track. At this point, Serenity knows which songs exist in the project. The next question is, when shall each song play? For that, we're going to use game mode changes. The idea is simple. When the application enters the menu game mode, Serenity should play the menu music. When the application enters the gameplay game mode, Serenity should play the gameplay music. Instead of manually calling the music player from random scripts, we will use Serenity's signals associated with game mode transitions. This keeps the behavior comfortable and avoids coupling the gameplay scene directly to the music system. Let's test what we have so far. We enter play mode from the Serenity entry point. When the menu appears, we shall hear the menu music. Then, when we start the game and the game mode changes to gameplay, the gameplay music should start. Now the game already feels much better, but we'll still have one very visible piece left: the game overflow. Right now, when the player dies, the project still uses a hard-coded text in the scene. We're going to replace that with a Serenity modal. At the moment, the game over message is part of the gameplay implementation. That's fine for a prototype, but as the project grows, these become harder to maintain. The game over UI should not be a hard-coded text object hidden somewhere in the scene. It should be a configurable UI element. And since this is not really navigation but a temporary blocking message asking the player for input, a modal is a much better fit. The player dies. The game asks the UI layer to show a game over modal. The modal displays the message, and the player can press the button to restart the level. That is the behavior we're going to build now. Before creating the modal definition, we need the text that the modal will display. Because Serenity supports localization, we shall not hardcode the visible strings directly into the modal. Instead, we create translation keys. For this modal, we need a title, and a message. Another thing we need is a signal and action for restarting the level. As usually, create it using the context menu. When created, modify the action in order to call the proper method. And now let's create a modal definition. This modal will be responsible for showing the game over message and its action buttons. Yes button will restart the game. The No button will end the game session and return to the main menu. Now we need to change the existing gameplay behavior. Currently, when the player dies, the game displays a hard-coded game over text. We are going to remove that direct UI behavior. Instead, when the game over condition happens, the gameplay should call the modal system and request the game over modal. The gameplay is still responsible for detecting death, but the modal system is responsible for presenting the UI. This is a very important architectural improvement. We're moving from scene-specific UI to framework-managed UI. That makes the game overflow easier to reuse, easier to style, easier to localize, and easier to modify later. Now let's test the complete flow. We start the game. The menu music starts to play. When we enter gameplay, the menu music stops and gameplay music starts to play. The player emits feedback sounds. When the player dies, instead of the old hard-coded game over text, Serenity should show the game over modal. Let's recap what we did in this video. We moved project-specific media and scenes folder out of the plugin folder, so future Serenity updates are safer. We copied sound and music assets into the project. We created AudioPlayerClipDefinitions for gameplay sounds and registered them in the game settings. We created MusicTrackDefinitions for the menu and gameplay songs, including BPM and loop information. We connected music playback to game mode changes using Serenity signals. And finally, we replaced hard-coded game over text with a Serenity modal using localization keys. This is a big step forward compared to the previous video. In the first part, the game was simply running through Serenity, and now, Serenity is actively managing the parts of the player experience. In the next video, we're going to fix one of the last prototype-style parts of this game, player input. At this moment, the player controller is still using Unity's all-input system, so next, we will migrate the player controls away from Unity's legacy input API and configure them through Serenity Player's input system. This will make the input flow cleaner, easier to configure, and ready for more advanced scenarios later.